Welcome to another Titus Timeout podcast. I'm Matthew McLaurin. In this episode, we'll discuss some more details about chill beam system design. Specifically, how close can you mount chill beams to one another? There are numerous factors that affect active chill beam diffuser selection and layout. From an air distribution standpoint, as their full name would suggest, are just diffusers. As a result, most of the same procedures and considerations that apply to overhead air distribution design also apply to active chill beams. We discussed in a previous episode that when used for perimeter heating, they should be placed parallel to the exterior glazing between 3 and 5 feet away. In this orientation, nothing prevents them from being placed end to end. Traditional recommendations for not exceeding a 10-foot active length still apply to prevent unpredictable airflow. A continuous look can be achieved using inactive dummy sections. The more challenging concern is when beams are installed parallel to one another when providing cooling to a large space. Placement relative to one another is critical in maintaining thermal comfort due to relatively long throw values, a characteristic that they share with conventional slot diffusers as a result of their design. In order to maintain comfort, we want to ensure velocities entering the occupied zone remain under 50 feet per minute. Our main focus is directly below where colliding airstreams meet. When these streams collide, a significant amount of their individual momentum is dissipated. The velocity entering the occupied space will depend on several key factors: separation distance between the diffusers, installed height, and the height of the occupied zone, which is dictated by whether the occupants are seated or standing. In general, the smaller the combined distance between diffusers and the height above the occupied zone gets, faster the velocity will be when entering the occupied zone. The Titus Active Chill Beam Selection software allows the user to enter the location of active beams with respect to each other and the installed height. Based on the selected beam configuration, the program will calculate local velocities entering the occupied space as well as temperature of that airflow. In this example, we'll look at the spacing between two 4-foot CBAL 24 beams. We'll consider the occupied height at 5 feet and a 9-foot ceiling height. Starting with a 14-foot on-center spacing, we can see that the velocity entering the occupied zone is only 35 feet per minute. We can then reduce the on-center spacing over there just to see how close we can get. At 10-foot on-center spacing, we're at 41 feet per minute. If we continue reducing at 4-foot intervals to 6 feet, we can now see that we exceed the 50 feet per minute rule, but have a 74.6 degree entering air temperature. For most people, this would still feel comfortable as this isn't 55 degree air. However, if we bump this back up to 8 feet, the velocity is 46 feet per minute, ensuring all will be comfortable. For more information on chill beams, please check out our previous webinars and podcasts on the Titus YouTube channel. Don't forget to subscribe while you're out there, and thanks for taking the time out with us.